Do you ever feel like time is moving faster lately? You're not imagining it. Something weird is actually happening to the Earth. We all know the Earth rotates, at least most of us do, unless you're part of the Flat Earth Society. In that case, welcome. But assuming the Earth really is spinning, we're told it makes one full rotation every 24 hours, right? Not exactly. The rotation of the Earth isn't fixed. It can speed up or slow down over time, and right now, it's speeding up. In fact, the Earth is spinning faster than it ever has since we started officially measuring its rotation. Those measurements only go back to around 1970, so this is the fastest the Earth has spun in at least 55 years. The rotation has been speeding up since about 2020. If any flat earthers are still watching, I'm sure someone out there thinks that timing is suspicious. The shortest day ever recorded happened in July 2024, when the Earth completed a full rotation about 1.66 milliseconds faster than 24 hours. To put that into perspective, a human blink lasts around 100 to 150 milliseconds, so this is about 1/100th of a blink. So the big question is, should we panic? Probably not. If you zoom way out and look at Earth's history, the planet is actually spinning much more slowly than it used to. About 600 million years ago, a day on Earth only lasted around 21 hours. Yeah, it's pretty confusing. Here's what's going on. A lot of different things affect how fast the Earth spins. The sun and the moon both play a role, and even the way Earth's mass is distributed matters. The sun is huge, but surprisingly, it has a pretty minimal effect on the Earth's rotation. If anything, energy from the sun slightly speeds Earth up, but that effect is tiny compared to the moon. The moon has a very strong influence on Earth's rotation, mostly through something called tidal friction. Here's a simplified version of how that works. The moon's gravity pulls on Earth's oceans, creating a bulge, what we call high tide. As the moon orbits Earth, it pulls that bulge along with it. But Earth itself is spinning faster than the moon is orbiting, so the bulge lags behind. That drag slowly slows Earth down. This process adds about 2 milliseconds to the length of a day every 100 years. Over a very long time, Earth's rotation would eventually slow until it matches the moon's orbit. But everything on Earth will be long gone before that happens, so don't lose sleep over it. On average, the moon slows Earth down, but right now, it's actually helping Earth spin faster. That's because the moon doesn't always orbit directly over Earth's equator. Sometimes it moves closer to the poles. This is called declination. When the moon is closer to the poles, it pulls less on the middle of the Earth and more on the top and bottom. That change actually speeds up Earth's rotation. This moon cycle is totally normal though, so it doesn't fully explain why Earth is spinning faster now than it has in decades. The final piece of the puzzle is Earth itself. How mass is spread around the planet has a big effect on rotation speed. Think about a figure skater. When their arms are stretched out, they spin slowly. When they pull their arms in, they spin faster. Earthquakes can do the same thing. When one tectonic plate slips under another, mass moves closer to Earth's center. That causes the planet to spin slightly faster. The changes are tiny, but they're real. The massive 2011 earthquake in Japan sped up Earth's rotation by about 1.8 microseconds. That's 1/100th of a millisecond. Again, about 1/100th of a blink. Water movement also affects Earth's mass distribution. Yes, climate change plays a role here, but in a weird way. As polar ice caps melt, water moves from the land into the oceans. When water shifts from the poles toward the equator, it should slow Earth down, like a skater stretching their arms out. But there's a bigger effect. Those ice caps are massive, and their weight actually squeezes the Earth slightly, making the planet bulge around the middle. When the ice melts and that weight spreads out more evenly, Earth becomes more spherical. The arms pull in, and Earth spins faster. So what does all this mean? Well, since the Earth has generally been rotating slower over time, we've been adding leap seconds to the standard day in order to keep it in sync with the Earth's rotation. This has happened a few times now. The most recent leap second occurred in 2016. So when we say one day is 24 hours, we're actually rounding down slightly. It's really 24 hours and a few seconds. But if the Earth continues to accelerate its rotation, then we might end up eventually having to take one of those leap seconds away, essentially bringing the length of a day back down closer to where it was when we started measuring the Earth with atomic clocks back in the 1970s. Unless you work on GPS systems or critical timekeeping software, this probably won't affect your life at all. There are way more serious things happening on Earth. This one is just interesting. Now for something really cool. NASA just released footage taken from inside the Sun's atmosphere. The video was captured by a spacecraft called the Parker Solar Probe. What you're seeing is the Sun blasting electrically charged particles into space. The big cloud-like shapes are part of the corona, the Sun's outer atmosphere. Everything rushing past the camera is the solar wind. The solar wind is a constant stream of charged particles that race through the solar system, creating what we call space weather. Earth is mostly protected by its magnetic field, but sometimes a massive chunk of the corona gets launched into space in an event called a coronal mass ejection. When those hit Earth, they can create beautiful auroras, and if they're strong enough, they can disrupt power grids and communication systems. We've known about this for a long time, but this is the first time we've seen it up close. The Parker Solar Probe was launched in 2018, and it had the goal of reaching closer to the Sun than any man-made object. It would essentially be the first thing to touch the Sun. That happened when the spacecraft made its first close approach to the Sun in 2021, when it entered the corona for the first time. Then the probe would fly out to Venus, where it would use the planet's gravity to slingshot itself back towards the Sun, getting closer and closer to the star with each pass. Right now, the probe is just over 6 million kilometers from the Sun's surface, well inside the corona. This is as close as it will get. It doesn't have enough fuel to keep adjusting its orbit, but it's already moving fast enough to avoid falling into the Sun. It will keep making close passes and collecting data as long as it can. Scientists are trying to answer some big questions. One of the strangest mysteries is why the Sun's surface is much cooler than the corona. The surface is about 5,500 degrees Celsius, but the corona reaches millions of degrees. You'd expect the heat to come from the center, but it doesn't. There's also the mystery of the solar wind. We know it exists, but we don't fully understand what creates it or what accelerates it into space. Even if we can't solve that completely, we want to get better at predicting solar storms. Right now, we usually don't know a coronal mass ejection is coming until it's already on the way. That doesn't give us much time to prepare. Most solar storms just create auroras and minor power flickers, but one day a massive solar storm will hit, and when it does, we'll find out what life is like without electricity, internet, or modern communication. So to sum it all up, don't worry about Earth's rotation. It's fine. Do worry about the Sun. It might kill us all someday. We probably can't stop it, but at least now we might see it coming.